3, add, subtract, and multiply polynomials. Example 1, add the first polynomial and the second polynomial vertically. X cubed, x squared, x to the 1, and the constant. I want to make sure that all of those terms are there just in case when I line them up vertically. I want to make sure I'm putting these in the correct column. X cubed, so I'm adding. X cubed would go here in the x cubed column. X squared would go in the x squared column. And the constant would go in the constant column. 2x cubed plus 1x cubed is 3x cubed. 6x squared minus 5x squared would be x squared. 3x plus nothing is still 3x. And then 11 minus 9 is 2. This is how I prefer to do them myself, actually. Let's look at what it looks like when you're doing it in the horizontal format. We have 3y cubed minus 2y squared minus 7y. And we are adding negative 4y squared plus 2y minus 5. Here we have a positive in front of the parentheses, so nothing is going to change on the inside. We only need to worry about this sign in between the functions when it's a negative. So I'm just looking to combine like terms. I have 3y cubed plus, there is no other y cubed over here, so it's going to be just 3y cubed. Next would be the y squared, so I have negative 2y squared and negative 4y squared. Negative 2, negative 4 is negative 6y squared. Next would be my y terms. I have a negative 7y plus a positive 2y. So negative 7 plus 2 is negative 5y. And then do we have a constant here? No. And then we have the constant here. Final answer. Example 2. Example 2 says we're subtracting the vertical form first. So we're subtracting this from this. How should I set that up then? We're subtracting 3x cubed from 8x cubed. That means that this one goes on top. X cubed, x squared, x, and the constant. So we're subtracting this from the second one, and we're subtracting. So I need to put a parenthesis because I need to subtract off all of the polynomial, not just the first term. X cubed, x squared, x, and the constant. Subtraction is where you really need to watch out how you're subtracting, what is the order that it should be in, and make sure you're subtracting off the second polynomial, not just the term of the polynomial. So when there's a negative out front of it, we need to change those signs. This one becomes negative, this one becomes negative, this one becomes positive, and this one becomes negative. 8 minus 3 is 5x cubed. Negative 1, negative 2 is negative 3x squared. Negative 5 and positive 1. Don't forget about those ones. Negative 5 and positive 1 is negative 4x. And then 1 minus 7 is negative 6. Now, subtracting horizontally. Subtract 5z squared from 4z squared. So here's my first one. 4z squared plus 9z minus 12, subtracting the second polynomial. 5z squared minus z plus 3. Again, when there is a negative out front of the polynomial, you need to make sure that you distribute that negative onto all of your terms. Minus 5z squared. A negative times a negative is a positive z, and a negative times A negative times a negative is a positive z, and then a negative times a positive is a negative 3. Now I'm ready to combine my terms. We have 4z squared minus 5z squared, negative 1z squared, and then 9z plus 1z is 10z, and then negative 12 and negative 3 is negative 15. Example 3, multiply polynomials vertically and horizontally. We have negative 2y squared plus 3y minus 6, and we're going to multiply y minus 2. So it's the same thing as regular multiplying if you're used to multiplying without lattice. It's going to be negative 2 times all three of these terms. Negative 2 times negative 6 is 12. Negative 2 times 3y is negative 6y. Negative 2 times negative 2y squared is a positive 4y squared. Now I'm ready to move on to the y. Y times negative 6 is negative 6y. I'm going to put that in the y column. Y times 3y would be 3y squared, going in the y squared column. And that's positive. And then y times negative 2y squared is negative 2y cubed. As you do when you're multiplying, you are going to add up what you have here. 12, negative 6 is negative 12y. 4y squared and 3y squared is 7y squared. And then we have a negative 2y cubed. Okay, problem B. Now we are going to multiply them horizontally. So we have x plus 3 times 3x squared minus 2x plus 4. So basically we're doing the distributive property. Starting with my x term, I'm going to multiply my x term 3 times. Once, twice, and 3 times. So x times 3x squared is going to be 3x to the 4th. We're adding exponents when we're multiplying. X times 3x squared is going to be 3x to the 3rd power. X times negative 2x is negative 2x squared. X times 4 is 4x. Now I'm ready to move on to 3. This is a positive 3. So 3 times the first one, the second one, and the third one. As I multiply, I'm going to put them in the correct columns. 3 times 3x squared is 9x squared. Here's my x squared column. 3 times negative 2x is negative 6x. And then 3 times 4 is 12. Now I am ready to add them up. We have 3x cubed, our leading coefficient and degree. 9 minus 2 is a positive 7x squared. 4 minus 6 is going to be a negative 2x, and then we have plus 12. Final answer. Example 4, multiplying 3 binomials. We are going to multiply in the horizontal format. So we have x minus 5 times x plus 1 times x plus 3. You just start by multiplying 2 of them together and then multiply to the third one. So we'll start with the first 2. X times x is x squared. And the middle term is going to be the inner and outer. So negative 5 times x is negative 5x. And then x times 1 is 1x. So we get negative 4x. Remember, you add them and then multiply them. So you're adding negative 5 and 1 to get negative 4, and then you're multiplying negative 5 and 1 to get a negative 5. And now I need to bring down the third binomial and multiply. All right, starting with the first term, we have x squared times x. x cubed, and then x squared times 3 is 3x squared. Moving on to negative 4x, we have negative 4x times x is going to be a negative 4x squared. So I'm going to put it in the x squared column. Negative 4x squared. Negative 4x times 3 is negative 12x. I don't have a column, so I continue on. Moving on to negative 5. Negative 5 times x is negative 5x. Putting it in the x column. Negative 5x. And then negative 5 times 3 is negative 15. Notice how I kept each one of these lined up horizontally. Here was my first term that I multiplied, my second term, and then my third term. But I could also see where I was putting them in the correct columns to make it easier at the end. And you just add up your columns. We have x cubed, and then we have 3 minus 4x squared is negative 1x squared. Then we have negative 12, negative 5x is negative 17x, and then we have negative 15. Final answer. So we have some special product patterns. If you catch on to these patterns, then it'll make factoring and multiplying much easier. We have a sum and difference, a sum and a difference. It's exactly the same variables in both parentheses, and we know that when we're multiplying a sum and a difference, we get no middle term. So x plus 4 times x minus 4 is going to be x squared, no middle term, minus 16. Next, we have the square of a binomial. We've been practicing these, and this is the chapter where you should really fine-tune this skill. When I have a binomial that's being squared, I know my first term is a squared. I know my last term is going to be b squared. It's the middle term that we need to work on. Remember, it's going to be 2 times the first term times the second term, because you're always going to have 2 terms in the middle that are the same for a binomial that's being squared. So 2 times a times b is the middle term. Let's practice it over here. The first term is going to be y squared. What's the middle term going to be? It's going to be 2 times 3 times y, which is 6y. And then 3 times 3 is 9. How about the second one here? The first term is going to be 3z squared times 3z squared, so that's 9z to the 4th. The middle term is 2 times 3 times negative 5 times z squared. I like to multiply my numbers first and then multiply the variable. So we have 2 times 3 is 6, times negative 5 is negative 30, times z squared is negative 30z squared. And then we have our last term, negative 5 squared, which is positive 25. Notice that I kept my signs in front of them when I was looking at that middle term. It's the negative goes with it, negative 2 times a times b. Finally, we have a cube of a binomial. The cube of a binomial, we actually have a technique that we like to use, but you can also use the formula here. We see that it's, let's look at the exponents first. This is a cubic, so it starts with a cubic. And then on the next term, the a is going down to a square, and that's the first time that you see the b term. Then on the next one, you see that your a exponent is still going down, so a to the third, a squared, a to the 1. And what's happening to the b term? It appears here, and then that exponent is going up. So as the a's are going down, the b exponents are going up. And then, of course, you have the 3's in front of them. When it's adding, it's going to be all positive. When we have a difference of a cube, it's going to be alternating, starting with the negative. Negative, positive, negative. We will be practicing these ones. Now, you should be really good at doing the first two. We're going to have to practice the binomial when it's a cube. All right, so if I look over here, what do we have? All right, x plus 2 cubed. We have the first term is x cubed. The next term, the degree is going to go down on the 3. So we're going to have x squared. The 2 is going to appear for the first time, 2 to the 1 power times the 3. So that should be 6x x squared. On the next term, the x degree should be going down by 1, so it should be x. And now the 2 is going to be 2 squared. We have 2 of them now. It was 1 2 here, and now it's going to be 2 2s. Remember, the exponent of the second term is going up. So now we have 2 squared, and we have to multiply to the coefficient, 3. So that's 4 times 3 is 12. So we should have 12x. And then the last term, there are no more x's. The second term was 2, 2 squared, and now 2 cubed is going to be 8. You're going to have to just practice to get used to that technique. We are just multiplying. What is this? Do you recognize what this is? This is a sum and difference, which means I have exactly the same thing in both parentheses, but a plus and a minus. So there will be no middle term. We get 3t times 3t is 9t squared, and then 4 times negative 4 is negative 16. Okay, how about a binomial, 2 terms being squared? We know the first term, 8x squared, is going to be 8x times 8x, which is 64x squared. We know the second term is going to be 2 times the first term times the last term. And then we have the last term is negative 3 squared. We just need to simplify that middle term. Eventually, you should just be doing that in your head. 2 times the first term times the second term. So we get 64x squared, and then we have 24 times 2 is 48. So negative 48x plus 9. All right, we're going to practice our cubic. We have the sum of a cube. We know that we have the first term being cubed. It's the sum of a cube, so we know it's all plus signs. Now we have PQ going down to 2. And this is where the second term comes in. It's going to be times 5 to the 1 power. Plus, our PQs are going down again. And our 5 squares are going up. We did forget one thing on this cubic. We forgot, or actually I forgot, about the 3 that's in front of this one and in front of this one. The 3. So we have the coefficient of 3. Our PQ cube squared 1. 5 to the 1 comes in, and now it becomes 5 squared. So I have my first term, my second term, and the coefficient. Plus, I don't have any more PQs left. And my second term is going up. 5 to the 1, 5 to the 2, 5 to the third power. That's how you want to think about this without just memorizing a formula. You're looking at the exponents and what's happening to them, because we're going to get into bigger ones than just 3. We can get all the way up to 7 just to practice what's happening with those exponents. We'll be looking at Pascal's triangle to help us with these coefficients. That's where the coefficients will come from when it gets a higher degree. For now, we can just memorize that when it's a square, there's a 2 in front. When it's a cube, it's a 3 in front. All right, let's simplify. We have a product being raised to a power, that's p cubed, q cubed. We have 3 times 5 is 15, and then p squared, q squared. We have 25 times 3, and then pq. And then we have 5 cubed. 5 times 5 is 25 times another 5, 5 quarters.